Today we'll see about access control list, ACL. Okay. So what is ACL?
ACL is complete or denied for particular user.
But what is ACL?
ACL
Level of access.
So it is a statement in which allow and deny access to
Okay.
an host.
Statement. Kind of rule it is.
that's rules
Kind of rule it is. Okay. And why these rules are used?
to control the network protocols.
To control the network protocols. Okay.
And traffic.
What kind of security?
For attackers.
Attackers. Okay. Basically, it is going to filter your network traffic. It is a set of rules that is used to filter your network traffic on the basis of whatever rules you configure, whether you want to allow a particular type of traffic or you want to deny a particular traffic. Okay. So you can say ACL is a set of rules that is used to filter the network traffic. Okay. Now, with the help of ACL, okay, with the help of ACL, you can either permit a traffic or deny a specific traffic. Okay. With the help of ACL, a traffic can either be permitted or denied. Okay. Means basically we have two actions, either permit or deny. Okay. Now, before going forward with the ACL, what is the rule?
Rules are predefined.
Set of
That
instructions.
set of instructions. Okay. How many types of rules are there? Type of rule.
Standard rules.
How many types? Three.
Fourth.
Four.
Reflection also.
Tell me.
Standard.
They are type of ACL.
Type of rules.
Type of rule. Three. Check the source and destination. IP address. Source and destination is what? Anything. This is applicable everywhere. This is applicable everywhere. Your ACL, your firewalls, everywhere it is applicable. This is a general thing. How many types of rules? Implicit and explicit. Only two types of rules are there. Okay. The first is implicit rule. And the second is explicit rule. What is an implicit rule?
Implicit inside. We should work inside.
Okay. Work outside. Okay. Yes. Predefined. Okay. And explicit. Correct. See, these two types of rules. Implicit rule. These are the predefined rule. Okay. These are the predefined rule. Okay. Plus, in case of ACL, these cannot be modified. Your implicit rule cannot be modified because these are predefined, kind of you can say inbuilt rules. Okay. And the second type is explicit rule. These are user defined rules. Okay, and since these are user defined, if user is defining a rule, means user can also modify this rule. So these can be modified. Is that clear?
The implicit rule is already available. Means
Yes, already configured by default. Predefined means already configured, that are kind of, you can say, inbuilt or by default. Okay. So in case of ACL also, we have some predefined rules or implicit rule. Okay. What is that? That is at the end of every ACL, there is an implicit deny statement. There is an implicit deny statement that denies all the traffic other than the ACL configured. Okay. Other than the whatever ACL you have configured, other than that, rest of the traffic will by default be denied. Okay. If you are permitting, so only that particular traffic will be permitted, rest of the traffic will be denied. Okay. If you are denying something, that will be denied, rest entire traffic is denied. Everything is denied, kind of you can say. Okay. No, it's not visible. Okay. Yes, it will not be visible. The implicit deny statement will not be visible or is not visible. It is not visible, but still it is present. Okay. This is clear. Right. Okay. So simply whatever ACL you configure, other than that, entire traffic will be by default denied. Okay. Now types of ACL. What are the types?
Standard is
And
Standard and
standard,
extended.
extended dynamic,
Standard and extended. Correct. Or if I say named and numbered.
dynamic ACL.
See, you can consider both the ways. Yes, please. Okay. See, there are two ways to configure or two ways to define your ACL. Named, there's a named method and there's a numbered method. Okay, named method and numbered method. Now ACL is two only. That is your standard and extended. But these are the two ways to define your ACL. Okay. Now in your named, you will have standard and extended. In numbered also you will have standard and extended. Okay. Okay. In the named method, what we are going to use? We are going to use names. And in the numbered method,
numbers.
numbers will be used. So what will be the numbers for standard ACL? Did you check? Or no? Not checked.
0 to 99.
See. Your standard will range from 1 to 99. Okay, and extended will range from
100 to
100 to
199, maybe.
199. Then this is the normal range for your ACL. Okay, then there is an extended range also available. Okay, what is that extended range? 1300 to 1699. Okay, and we have 2000 till 2699. Okay, so if you see a number between this range, if you see a number between 1 to 99 in the access list, or 1300 till 1699, that is a standard ACL. If you see a number between 100 to 199 or 2000 to 2699, that will be a extended ACL. And in case of named, we will just simply use the names. Okay, this is clear. Okay. In case of packet tracer, you will see only this standard range, means normal range. This is C. What is it? This is the normal range. Okay, and this is the extended range. Okay, so in case of packet tracer, you will see the normal range only 1 to 99 and 100 to 199. This is the range you are going to see in case of packet tracer. But in the real routers, you have this other range also, extended range. Okay, this is clear. Now, what is the difference between your standard ACL and extended ACL? What is the difference? Okay, you guys didn't check. Okay. One side standard. Second side we will have extended. Okay. The first difference is the numbers, right? That it will use the numbers from 1 till 99 and also 1300 till, oh, not 16, it is 1999. My mistake. Okay. Then it will be 100 till 199. And then 2000 till 2699. Okay. Just make the correction. This is not 1699. This is 1999. Okay. Other differences? Your standard ACL can, with the help of standard ACL, you can block a single host. Okay. A subnet or a network. Okay, these are the things you can block with the help of your standard ACL. In case of extended, can block a host, a subnet, a network, and a service. A specific service you can block. let's say, and a particular service. Okay. Then when you're using standard ACL, all services are blocked. Okay. And here a specific service can be blocked. Okay. Other than that, in case of standard ACL, bidirectional communication is blocked. Means both the sides, no communication. Here bidirectional communication is blocked, and here you can say unidirectional or the traffic. Okay, unidirectional. Let's say. Here unidirectional traffic is blocked. Then here you can filter the traffic based on, you can say traffic is filtered based on source IP address only. Okay, but in case of extended ACL, traffic is filtered based on source IP, destination IP, protocol, and port number. Okay, you can filter the traffic based on these criteria. Is that clear? So these are few of the differences between your standard ACL and extended ACL. Yes, one more difference. Your standard ACL, it is applied closest to the destination. Okay, and your standard ACL, it is applied close to the source. Here. Okay.
There are all services are blocked.
Everything, all the traffic will be blocked. No communication. Means with the help of standard ACL, you cannot block a specific service. But with the help of extended ACL, we can block a specific service. Okay.
If you enable standard ACL, it will block again.
Okay. Based on the rule. Okay. Whatever rule you configure. Now see. Let's take before that. Now we have seen about the ACL, type of ACL, differences between standard and extended. Okay. Now your ACL is applied in two directions. Okay. ACL is applied in two directions. Okay. What are those two directions? First is inbound. Okay. And second is outbound. Okay. What does it mean with the inbound? Means for incoming traffic. Okay. And outbound means
Outgoing traffic.
for outgoing traffic. Okay. Or the traffic that is incoming that is also known as inbound traffic. And the traffic that is leaving or going outside, that is outbound traffic. Similarly, the interface on which the ACL will be applied in the inbound direction, that interface will be known as inbound interface. The traffic on which the ACL will be applied in outbound direction, that is the outbound interface. Okay. Let me say here. Applied for outgoing traffic. Okay. On the inbound interface. Okay, the interface will be known as inbound interface, and the interface on which the traffic is leaving, through which the traffic is leaving through the router, that will be known as outbound interface. This is clear? Okay. Clear? Now, how do you define the ACL? Okay. How do you define the ACL? That we'll discuss after. First of all, we'll do the lab. Or let me do one thing. First, I'll tell you what is the syntax of the command, and then we'll define. This is not it.
The difference like standard and very close.
Okay. Now see, if we see how many types we will have to study: named standard, named extended, numbered standard, numbered extended. Total 4 types we have to discuss. Okay. See. So first of all, I'll tell you numbered standard ACL. Okay. So how do you create a numbered standard ACL? Simply, you'll give the command access-list. Okay. You'll give the command access-list. Then you'll give the statement whether you want to permit or deny. Okay. Either permit or deny. Okay. Before that, access list number also you have to give. Okay. So for standard, the number will be between 1 to 99. Okay. Then you have the option to define either you want to block a particular host. Okay. So in that case, you will write here host, or else you will give here the source IP address. Or if it is network, then the network ID. Okay. Is it clear? So source IP address, or you can say you will give here network ID. Okay. After that, you will give here the subnet mask. If you are using the word host, in that case, you do not require a subnet mask, because this will be used whenever you want to block a single IP only. Okay. Otherwise, when you're using the network ID, you will have to use the subnet mask. Is that clear? If you are using the source IP address, then you will have to use the subnet mask. But if you are using the word host, you do not need to use subnet mask. Okay. Now see. After the subnet mask, what will say? Just that's it. This is the syntax for your standard ACL. Okay. Now, what will happen? By default, whatever ACL you create, other than that, remaining all the traffic will be denied. So if you want to permit rest of the traffic, because we will have to permit, right? So you have to say access hyphen list. Then again, whatever is the number, same number you have to use here. If in this rule you use the number 1, then here also you have to use the number 1 only. Then after you have to say permit n. Okay. This is how you are going to create the standard ACL. Yes, anything. Okay, we'll show you. First of all, I'll show you the practical. Then you have to apply the ACL. So first of all, what we did, create the access list. And now we will apply it. Apply the access list. So to apply the access list, what you're going to do, on whatever interface you want to apply, you have to go to that interface. So you'll give the command interface, and then you'll have to give interface name. Interface name. Now, once you are inside the interface, you have to give the command IP access group. Then here you have to give the ACL number, whatever ACL you have created. Okay. Then you have to give the direction, whether you want to apply inbound or outbound, either inbound or outbound, whatever direction, okay, you want to apply. This is clear?
What ACL number range from 1 to 99?
Whatever ACL number you will use here, the same number you have to use here.
It's like a privilege level or?
No, not like privilege level. This is list number. Okay. This is clear? Okay.
Sir,
Noted. Yes.
sir, question on subject mask, can we use wildcard mask?
No. In case of
Because
ACL,
outside
yes. You're right. In case of ACL, this will be wildcard. In we are going with the firewalls, there it is subnet mask only. Here you will have wildcard. Okay. In access list, it will be wildcard only, no subnet mask. Okay. There is no subnet mask concept. Okay.
And this is inbound or outbound?
Yes, inbound or outbound. In or out. See, the word will be in or out only. In means inbound, out means outbound. So let's do one thing. Let's create the ACL and then we'll see. Yes.
Router, we use only
Yeah, router wildcard mask. If you're going with the firewalls like ASA and all, there you have to use subnet mask. In there is no wildcard concept. Okay. Consider these are the PCs. Okay. This is PC1. This is PC2. PC3. PC4. Okay. Network here, let's say we will use 10.1.1.0/24. Here we will use 10.2.2.0/24. And this one, let's call it as R1, R2. And this one is R. So between R1 and R2, I'll use 192.168.12.0/24. Between R2, R3, 192.168.23.0/24. Here, let's say this is on R2, so I'll use 20.1.1.0/24. And here it is on R3, so 30.1.1.0/20. Okay. In here, we will have the IP 10.1.1. Let's say 10. Here we'll use 10.1.1.20. Sorry, 10.2. Okay. Then here 20.1.1.40. And let's say this is 30.1.1.30. Randomly any IP you can take up to you. On the router R1, all IPs will be .1. On the R2, all IPs will be .2. On R3, all IPs will be .. Okay. So here will be all .1, .2, .3. Okay. Okay, first of all, let's go with the PCs. Let's say PC1. Enable, configure terminal, then change the host name, PC1. Then, first of all, let's disable the IP routing. So I'll say no IP routing. And I'll set the default gateway. So IP default gateway, and for this, the default gateway will be R1 IP address, that is 10.1.1.1. Correct. Then interface Z0/0 IP address 10.1.1.10 255.255.255.0. Then no shutdown. This is clear. So this is done. Also, I want to enable telnet here. Okay. So I'll say line VTY 0 to 4. Then I'll give the password. Let's say 1, 2, 3. Login. And I want to allow only telnet. So I'll say transport input telnet. This is clear. This is the configuration for your PC1. Let's copy this. And let's do the configuration for your PC2.
If you want to give SSH means transport input SSH, right? Sir?
Yeah, that then it should be transport input SSH, and also you need to change create a domain name and crypto key.
Okay.
So this is PC2. Default gateway will be 10.2.2.1 for this PC.
Yes.
And the IP address will be 10, 2 to 20. Then this configuration will remain same. Okay, let's go with the PC3. PC3. So PC3 IP addresses. Default gateway will be 30. 30.1.1.3. Here, right? Then IP address will be 30.1.1.30. Correct? Remaining configuration is the same. Now PC4. IP address will be 20.1.1.2. Gateway, I mean. The IP address will be 21.1.20. Correct? Because if you see here, 21.1.40. And remaining configuration is the same. Okay. All PCs configuration is done. Now let's do the configuration for R1. Enable configuration terminal, hostname, R1, then interface Z0/0, IP address. What will be the IP address on interface Z0/0 of R1? Then 255.255.255.0. Then after, no shutdown. Correct? Copy, paste. Interface Z0/1. What will be the IP address? 2.2.1. Interface Z0/2. IP address will be 192.168.12.1. Correct. Then I want to reach all the networks, so I will create a default route here. IP route. Then my next stop address will be.
Sir, if you use default route on R1, you have to use default or static route on R2 and R3 also.
I can use, see, if I want to reach from R1, on R1, these are the networks. This one, all are directly connected. Beyond this, I don't have any networks this side. So means these networks I can reach because I have directly connected. And if I want to reach these networks, I will be coming this side. So I can use default route. Similarly, on R3, this is connected, right? So I can use default route here, this side. But if I'm talking about R2, R2 will be connected to these networks only. But when R2 wants to reach 10 and 30, R2 will have to use a static route. So on R2, I will be creating static route. R3, I will be creating default route again. Okay. So my 192.168.12.2. Done the configuration for R1. Let's go and do the configuration for R2. Now in case you can use anything. That is up to you. On interface Z0/0, I will have the IP what? So I'll change it. Z0/0 I will make it, and here the IP will be 12.2. Then interface Z0/1. So Z0/1 will be 20. So let me do it. 20.1.1.2. And Z0/2 will be 192.168.23.2. This is done. Okay. Now, if I want to reach the 10 network, in the subnet mask is What will be my next stop?
12.1.
12.1. And if I want to reach 30, then my next stop will be 23.3. See, from R2, if I want to reach 30, this is the next stop, 23.3. Clear?
Sir, but we have not configured the 10.2 network for PC2.
Okay, PC2. Let's give one more row. No problem. 2.2. Now done. Okay. This side it will reach via 12.1. And on R3 side, it will reach via 23.3. And this 20 network, this is already connected. Correct? Now let's go and make the configuration for R3. R3. Host name will be R3. Interface Z0 by 0 will have the IP 23.1.
3.
Okay, 192.168.23. Interface Z0 by 1 will have IP 31.13. Correct? Is there any interface Z0 by 2? Then delete. IP route, and this will be 23 dot. This is clear with everyone. Any doubts in the configuration? No? Okay, let's copy paste the configuration. EC1, CLI, no, paste. PC2, copy, CLI, paste. PC3, copy, CLI, no, and paste. PC4, CLI, no, paste. Then R1, copy, CLI, no, paste. Copy, R2, no, paste. R3, copy, CLI, no, paste. This is done. So now see what is the by default behavior of your router, that if any packet is coming, check the destination IP address, check the route, and then forward it. Correct? So right now we should be able to ping from PC1 to PC2, PC1 to PC4, PC1 to PC. We should be able to ping everywhere. Let's check. Ping 20, 10 to 20. Able to ping? Okay. What about ping 21.140? Your PC4, right? 21,140. Yes, Vincent.
Sorry, the routers is connected directly. You given us this one default route. Apart from that, your router static route, right, sir?
One default route on R1, one default route on R3, and 3 static routes on R2. Because
So we can't do all default route apart from static route.
no, if you on R2, if you make a static, I mean default route, your router will get confused which side to forward the packet. So what it will do, one time it will forward this side, one time it will forward this side. Doesn't matter for which network the traffic is destined. Okay, so to avoid that scenario, we have used what? Static routes. If you want, you can use RIP, OSPF, AGRP, that is your choice. Okay. Yes. So right now, if you see, we are able to ping everywhere. 30.1.1.30. See, initially the R process will take some time, so now it is committed. Okay, and if I want, if I can take telnet also, I can say telnet, let's say 10.2.2.20. Able to take telnet. What password did I set? 1, 2, 3. See, in the PC2. If I say telnet 21,140, 1, 2, 3. PC4. If I say telnet 31,130, 1, 2, 3. I'm able to take telnet and communication, right? Everything is here. Now what we are going to do, we want to filter the traffic. We want to filter the traffic. So we will use ACL. So first of all, we are going to create standard ACL. Okay. And according to the standard ACL, is it not connected? So according to the standard ACL, what we are going to do, our task we will keep that your PC1 should not have communication with PC3. PC1 communication with PC3 should be blocked. But PC1 should have the communication with PC2. This communication should be there. PC1 should have communication with PC4. This communication should also be there. Is that clear? Only what we want to block? PC1 communication with PC3. Is that clear? Okay. Means this is only the requirement that you have to block only this communication. Rest of the communication should be available. Okay. Now see. So right now we are not specifying that, okay, which protocol we want to deny, right? So we will deny everything. Okay. Now, if I will deny everything, that means my PC1 should have no communication, no ping, no telnet, nothing with the PC3. This is clear? Okay. Now see. If I apply the rule on R1, okay, see this thing. If I apply the rule on R1, I have 3 interfaces where I can apply this rule, where I can apply this ACL. Okay. Out of these, from where my traffic will go? PC1. Okay, if you see, my traffic will be going like this, right? This side. Correct? Okay. So, which will be the inbound interface here? Which will be the inbound interface on R1? 0/0. This interface will be inbound. Which interface will be outbound? 0/2. This will be your outbound. Okay. Means on these 2 interfaces, I can filter the traffic. Now, according to you, on which interface I should filter? Just anything you can tell. 0/0. Let's say I filter on this interface. What will happen? I will say here ping. Okay. Then let's say I will say 30.1.1.30. Correct. So a packet will be generated here, ICMP packet. That will have the source IP, destination IP. Okay, and forget the source MAC and destination MAC. Only source IP, destination IP, because router will check only the IP address. Then source IP will be 10.1.1.10. Destination will be 30.1.1.30. Correct. This packet will arrive on this interface. Now, since we are creating standard ACL, router will check what? Filtering is done based on the source IP address only. And let's say on this router, I have defined a rule that if source is 10.1.1.10, the action will be denied. The packet arrived on this interface. Router will check what is the source IP address. 10.1.1.10. Is it matching the rule? What should be the action? Deny. This packet will be dropped here itself. Okay. Let's say I was going to 30. Fine. If I'm going to 10. Let's say if I say ping 10.2.2.20. Again, packet will be generated. Source will be 10.1.1.10 only. What will be the destination? 10.2.2.20. Again, this message will arrive on this interface. Router will check what?
Source.
And action is? This is
Can you
fulfilling.
say it again? Sorry.
Yes.
Yes, sir. This source IP, destination IP, deny that thing.
Yes, because we have created the rule. This you understood, right?
No, sir, that only I not understand.
This you didn't understand.
Yes, sir.
This is the ACL, standard ACL rule we have created. Okay. This is standard ACL rule. See, what we are saying here is, what we are saying that access list, we created a number and then we are just checking about what? Source IP address. Only source IP address. And we will be giving the action what? Deny. So it will just check the source IP address. Okay. So
Okay, sir. Okay.
the rule will be something like this, and even your PC1 will not be able to communicate with PC2. And if your PC1 tries to communicate with some other IP, let's say also 20.1.1.40. Again, source will be 10.1.1.10 only. Again, rule will match and traffic will get denied. So means if I apply on this interface, everything is denied. This is getting fulfilled, no problem. But other than that, this communication is also getting denied. Correct? Okay, not a good idea. Because even if I permit rest of the traffic, still it will check what? Source IP. And every time the source IP will be this only. Okay, means on the interface Z0 by 0, I cannot filter. If I filter, everything is denied. Let's go with the second interface, the outbound interface. Again, the ACL is what? If the source is 10.1.1.10, action will be denied. Correct? Now let's say this PC tries to ping 30.1.1.10. Correct? ICMP will be generated. Who will be the source? 10.1.1.10 will be the source. Packet will come on this interface. Now this time we are not filtering on this interface. Okay. So the packet will come here on the interface Z0 by 2. 0 by 2 will check. Is the source 10.1.1.0? Denied. Okay. This is good. Your PC1 is not having communication with PC3. Next, we will give the command. Let's say ping 10.2.2.20. Okay. Packet will be generated. Who will be the source? Correct. Now, where is 10.2.2.20? Sorry. Yes, 10.2.2.20. Where it is? On the interface, Z0/2. So the packet will come to the router. Router will see in the routing table that, okay, it is on the Z0/2. The packet will come this side and the reply will come. They will have the communication. But when you try to communicate with 20.1.1.40, the packet will again come on the interface Z0/2. Router will again check. Source IP what? 10.1.1.0 denied. Means, okay, we have communication from PC1 to PC2. This is there. But from PC1 to PC4, this is getting denied, and this was not our idea. This is the reason that we never apply your standard ACL on the source side. Closest to the source, we do not apply, we apply it closest to the destination. If I apply the same rule on this interface, this will be the inbound interface, correct? For R3, this will be the inbound interface. Why? Because the traffic will be coming like this from PC1 to PC3. So this is the inbound interface. So on this interface, I will apply that if the source is what? 10.1.1.10, action should be denied. So standard ACL, you will always configure closest to the destination. What is our destination here? Just apply it closest to this. This is the router where we will apply. Now, if your PC1 tries to communicate, okay, if your PC1 tries to communicate with PC2, the traffic will never come here, so it will not get filtered. If it is trying to communicate with this PC, still the traffic is not hitting here, so will not get filtered. Only when the traffic is trying to pass to PC3, in that case only the traffic will hit this particular rule and it will get filtered. Is that clear? So this concept is clear, that your standard ACL will be applied closest to the destination.
But then the router tree on can we apply the GA0 special?
Yes. If he is applying on this direction, that will be outbound direction. Up to you.
Direction is like the return direction.
No. Again, the request will be blocked. Why? Because the traffic will be going outside from this interface for the PC3.
Okay. Mentioning alone, we have to discuss how.
Yes, you have to decide whether inbound or outbound. How the whether the traffic is incoming or outgoing. See, if you apply here, so the traffic is what? Incoming here. So this will be applied in the inbound direction. And if we talk about this interface, the traffic will be leaving for 30. So it will be exiting your router. So if the traffic is exiting the router, that will be applied in the outbound direction.
But IP address group we have to mention as
Out. Yes. Is that clear? So right now we will be applying C. You tell me which interface, Z0/0 or Z0/1, which interface you want to see. Where I should apply. Anywhere we can apply. That will depend, inbound or outbound, that's it. Okay. Now let's go and create the rule. See. We'll go to R3. Enable, configure terminal. Right now, if I say do show access list, do I have any access list? No. Okay. Right now, I do not have any access list. Now, what I'll do, I'll create an access list. I'll say access -list, and you can see the numbers. 1 to 99 is standard, 100 to 199 is standard. Let's say right now I'm creating my first ACL. I will give the number 1. Okay, you can choose any number between 1 to 99 for standard ACL. Based on this number only, your router will decide whether it is standard ACL or extended ACL. Okay. Now you want to permit or deny. What will be the action? Deny. Deny. Then you want to deny anyone or a particular IP address or a single host address. Right now, I want to deny only, let's say, for example, simply 10.1.1. Not 10.1.1.0, this 10.1.1.10. Okay. Yes. If you are blocking a particular IP, see how your syntax will be. You will say host and then 10.1.1.10. This is one way. Okay. Another way, you can say the IP is what? 10.1.1.10, and then wildcard for /32 will be all 0, because we are blocking a particular IP address. If you are blocking an entire network, let's say 10.1.1.0 network, 0.0.0.255. This is how you are going to define it. Okay. So let's say right now we will block only one single IP. So I'll say you want to block host 10.1.1.10. This is clear. Okay. Now we need to apply it. So on which interface I should apply it? Z0 by 0 or 0 by 1? 0 by 1. Okay, let's go and apply it on the 0 by 1. So will be applied inbound or outbound? Outbound. Okay.
Oh,
Yes. So go to the interface Z0 by 0, then say IP, access group, then the ACL number is 1, and you want to apply it in the outbound direction. And hit enter. Now if I say do show access list, see how many entries I created here. If you see here, how many entries I created for ACL? Only one. But when I check, there will always be some space in the bottom. Why? Because there is a hidden implicit rule. What the implicit rule says? Deny any. So your ACL is always matched in the sequence. First of all, whenever the traffic is coming, match with the first line. If it is matching, take the action. If it is not matching, go to the second line. Is that clear? So let's say when the source is what? 10.1.1.10. It will match the first line and deny it, take the action. If the traffic is matched here only, it will never check the second entry. Okay. It will always check line by line only. Is that clear? Okay. Now let's see. So we have denied and we have applied the ACL. Now let me go and try to ping from PC1.
So here after the dealing statement, rest of the traffic will be
Denied.
We
I'll show you. See. 30.1.1.30. Am I able to ping now? So your PC1 is not able to ping what? PC3. Is it able to ping PC2? Let's check. 10.1.1. Sorry, 2.2. Able to ping? Is it able to ping PC4? That is 21.140. Able to ping. So these conditions we have well and good, no problem. But when your PC2 also tries to ping, we didn't create any rule for PC2. But when your PC2 also tries to ping the PC3, ping 30.1.1.30. Oops. Double dots. See, even it is not able to ping. Even your PC4 will not be able to ping. Why? Because there is an implicit deny statement. Okay. So what we have to do? We have to permit rest of the traffic. How we are going to permit the rest of the traffic? See. Whatever command you use to create the ACL, what number we gave? 1. Now the same number I will use. So I'll say access -list 1 and I'll say permit any. Okay. So earlier when I checked my ACL, it was showing only one entry. Now see. Do show access list. Now again below that, there is again one more statement. Deny any. So what will happen? Let's say when my traffic is coming from 10, it will match on the first rule and the action will be taken what it is? Deny. When the traffic is coming from 10.2.2.20, will it match the first rule? No, because here is 10.1.1.10, not 10.2.2.20. Will not match. Go to the second line. Permit everything. Already matched. So it will never go to the third statement. So that's why we use a permit statement. Okay. So in your ACL, make sure whenever you create a ACL, your deny statements should come first. If you give permit any statement first, everything will be permitted on the first statement itself. Okay. So always your deny statement should be coming first. Okay.
So what is this?
This one.
This one. No, sir, this one. 10
this one. These are the sequence numbers. Okay. And by default, these sequence number are separated by 10. Okay. Later on, I'll show you that you can use the sequence number. Let's say I have given permit any statement. Now I want to deny, let's say, for example, also 10.2.2.20. So when I will give a command like this, by default, it will take the sequence number 30 and it will come below this one, below the permit statement. So when the traffic will come from 10 to 20, it will not match here, but it will match here and it will be permitted, not denied. So in that case, what we can do, we can use a sequence number, manual sequence number like 15. And if I give the sequence number 15, it will be coming in between 1 and 2. Okay. It will be coming in between these two. So if it will be coming in between these two, means there will be one entry, deny 10.1.1.10 having the number 10, then 15 this, then 20 will be permit any. And then you have the implicit deny any. Yes, we can pick.
Not like 10, 15.
No, not a requirement. You can go with 11, 12, 13, 14, like that, anything. But should be in between.
The access number, we mentioned 1. So
Yes, you can use between 1 to 99 any, up to you. Okay.
but here you are again use 1.
Yeah, because this has to, I want to add the entry in the same list. What is a list? List is having multiple entries, right? So in the same list, the number of this list is 1. So in the first list only, I want to add another entry. See, there is one ACL, access control list. This is the list. Inside the list, you have ACE, access control entries. Okay. So there will be multiple entries. So earlier I created only one entry. Now in the same list, in this particular list only, I want to add one more entry like this. So what I did, I gave the command access list 1, that in this list 1, add another entry, that is the permit any. So that's why you have only this statement here, permit any.
But if it is in another
Then it will not be applied, because here what you have applied, you see on the interface, which list you have applied? One only. Okay. And here mention one more rule on a single interface. Okay. Here make one more rule about ACL, that on one interface, you can apply only one ACL in a direction. Okay, only one ACL you can apply on one interface. So if you have already applied access list, let's say for example, if you have already applied access list number 1 in the outbound direction, then you cannot apply access list number 2 in the outbound direction. If you do so, your 1 will be removed. Okay. This is clear.
Can add more access list inbound.
Yes, you can do that. I'll come to that, don't worry. Okay, in the numbered method you will not be able to change. It can be changed only in the named method. Okay, so standard access list clear, numbered standard. Okay, now what I'll do, I'll remove the access person. So I'll say no access list 1. No access list 1. So access list is removed. You can check. Okay. And then I'll say no IP on the interface. I'll go. Do show running interface v0 by 1. No. Pipe section access group. The interface z0 by 1. This was the command I used. And I'll remove this. Okay, ACL has been removed. So now my PC1 should be able to ping. Okay. This is the default situation. Correct? Okay. Now we will go with the next method, that is your named standard. Okay. This is the numbered standard. First we'll complete standard, then we'll go with the extended. Okay. So named we have done or numbered we have done. Second will go name standard ACL. Okay. So again, first of all, you will create the ACL. See, what is the difference? Whenever you use numbered method, your command will start with the word access list. Whenever you're going with the named method, your command will start with the IP access list. Okay. So IP access list, then you'll say this is a standard access list. And here you will define the name of the ACL, whatever name you want to give. Okay. This is clear. Then after, you will go to the sub prompt. And in the sub prompt, you first have to give the permit or deny statement. And then again, the same thing. Whatever source, IP address, host, the same thing will be there. Okay. The same scenario will be there. Same thing. Okay. And if you want to permit rest of the traffic, then you will write permit any. To permit rest of the traffic. Okay. Is that clear? Then applying the ACL, similar, exactly similar. Just instead of ACL number, you will use ACL name. Okay. Instead of number, we will use name. Here you will use the ACL name. Okay. So this is how you are going to create named standard access list. And if you want to change the sequence number, then before the permit and deny statement, you will have to give the sequence number. Okay. If you want to add an entry in between, so before this permit statement, you can even assign the sequence number. Okay. This is clear. Should we apply it? So this time earlier, what we did? Earlier we blocked the communication from PC1 to PC3. Now we will block the communication from PC2 to PC3. Okay. Let's go and apply. Command will be IP access list standard, and let's say the name I want to give here is block PC2 to PC3. I can give the name so that whenever I look at the access list, I can know that why I have created this access list. Name is given. Now, my action should be deny host. And what is my source IP address? 10.2.2.20. And then I want to permit rest of the traffic. So I'll say permit and done. Access list is created. Now apply it on the interface. So you'll say to apply it interface, which interface earlier we applied, let's say on the Z0 by 1. This time we will apply on Z0 by 0. See, you can apply there also, no problem. Okay, but I'll show you that both ways you can apply. So earlier when we applied on Z0 by 1, we applied in the outbound direction. If we are applying on the Z0 by 0, we will be applying in the inbound direction. So you will say IP access group, give the name here. Copy, paste, and then I want to say inbound. Clear? Now check. This time your PC2 will not be able to ping. Ping 30.1.1.30. What it is saying? You undeliverable. Okay. But what about your PC1? Ping 30.1.1.30. Able to ping, and even your PC4 will be able to ping. Okay, you can check. Because we have permitted rest of the traffic. The ARP process will happen and then they will be able to ping. See? Hmm? No. What I said, bi-directional communication is blocked here. In case of standard ACL, bi-directional communication is blocked. Clear? Okay. So standard ACL is clear. Name standard, numbered standard. This is clear. Next is your.
You want to apply it in both directions.
Then interface Z0/1.
But already we have ACL.
That I already removed.
Okay.
Okay. If you want to apply for both of them on the Z0/1 and outbound only, then in the same access list, you will have to create the entry.
Yeah, that number then.
Yeah, not numbered. You can edit the numbered access list using the named also. How? If let's say you have the access list number 1, so you would say IP access list, then standard, and here you would use the name, let's say standard and 1. Then let's say it was already having the entries 10 and 20. So you would say 15. Okay. Then you would say deny. And let's say 10.2.2.20. That's it. And now if you check, do show access list. So you see the access list number 1 and sequence number is what? 50. So it would come between the 10 and 20 of the access list number 1 where we denied PC1. Okay. So in the same access list, if you add the entry, so it will do the work. Is that clear? All right. So no access list 1. No.
Maybe show IP that access group is still like two.
Only 1. That will be only 1 entry. Because in one interface, we can apply only 1 ACL in that direction. Okay. So no access list. IP access list standard. Okay, this is how you will remove the named access list. Okay. No IP access list standard and the name. So check, do show access list. Nothing.
So now both of this access are in inbound direction.
Which one?
Block PC2 to PC3 is an inbound.
Yes.
This access list 1 was.
No, I didn't apply this. I just showed you that you can use manual sequence number also, as well as you can edit a numbered access list using the named method also, using the command IP access list standard, and instead of giving the name, here you will give the number. Okay. All right. Then interface Z0/0. No IP access group and inbound. Everything is removed. Let's check whether your PC2 is able to ping or not. Able to ping. Okay. Standard is clear. Now we'll move on towards the extended. So first of all, we'll go with the numbered extended. Numbered extended ACL. Okay, again in the numbered method, you will use the numbers only. So first thing what we're going to do here, create the access list. And when creating the access list, you'll use the command access -list because this is a number. Then you'll use the number between 100 to 199. Then you will use the action whether you want to permit or deny. permit or deny. Then you will be using the protocol here, that which protocol you want to permit or deny. Okay. Then you'll give here either host, either source network ID. Okay, the same thing you can use here. Then the source mask, sorry, wildcard. Source, I'll write WC wildcard. Okay. Then after for destination, okay, you'll say destination. Again, here also you can give the host also, because your destination can also be a single IP address. So either host or destination IP. Yes.
But in the standard ACL, you can do per interface for the standard ACL, right, sir?
Yes.
Per entry.
Sorry.
Per ACL we can create in per interface, correct, sir? Per one interface.
No, you can create ACL for any interface. Okay, but on one interface, only one access list will be applied. Just make sure of that.
One access list. But in the access list, we can make
Multiple entries.
multiple entries.
Yes, yes, you can have it.
Okay.
And then finally, port number. Okay, so you can see how many criteria you specify here in case of extended. Okay, then if you want to permit rest of the traffic, same thing. Access -list. And then you will give the number between 100 to 199. Then you will say permit. Then you want to allow rest of entire traffic. So permit IP from any source to any destination. Okay. Then applying the access list, application is exactly similar to your standard. This one. How you apply the ACL? This is exactly similar. This is how you apply your extended access list. Okay.
Any doubt?
Any source, any destination. Because in extended, we have to match source IP, destination IP, protocol, and port number. Yes, Naveen, any doubt?
For a network ID, we have to type in a wildcard mask.
Yes, if you are using a single IP, just use the word host and then simply the IP address.
If I use without host name, then type the particular
IP address and then wildcard. Okay. Same like this portion is same like your standard only. This is clear? Noted? Okay, then let's go and create the ACL. So this time, what task we will keep here? Okay. Yes, problem noted.
Yeah.
What will be our task here? The task I want to keep that, okay, on the PC3, I have telnet configured and I'm also able to ping, means I have ICMP configured. So first task we will keep that your PC1 should be able to ping. Okay. Or let's say should be able to take telnet for PC3. Telnet should be allowed. Telnet should be allowed. But PC1 should not be able to ping PC3. ICMP we want to deny. So if you see, if I allow rest of the traffic, everything will be allowed. So ultimately, what I have to give here, one statement that I want to deny PC1 to PC3. My PC1 should not be able to ping PC3. Okay, this is the task. Now, sir. Now, since I will be matching source, destination, protocol, and port number, I do not need to apply it here. I can apply it anywhere on the R1 also, R2 also, R3 also, because only a specific traffic that is going from PC1 going to PC3 having the protocol what ICMP, and whether we want to block ICMP echo request or reply. According to that, if the specific traffic is matched, then only it will be blocked. Otherwise, it will be allowed. So now you can filter on PC, I mean R3 also, R2 also, R1 also, doesn't matter. And on any interface you can filter. Okay. So right now the communication will be happening from where? Here to here. So let's say we will filter closest to the source itself. Okay. Now if you want, you can filter on the Z 0 by 0 also, 0 by 2 also, doesn't make any difference. Okay. If you filter on Z 0 by 0, it will be inbound. If you filter on Z 0 by 2, it will be outbound. This is clear? Okay. Which interface I should filter? Inbound. Okay, we will be filtering on interface Z0 by 0. Okay. Now let's go and create the ACL. So when PC1 will try to ping PC3, the packet will be ICMP echo request or reply? Request. So we will be blocking the ICMP echo request on the interface Z0 by 0. Now focus. You'll create the ACL access hyphen list, or before that, first check that your PC1 or R1, I mean PC1 is able to ping. We'll check that thing. That able to ping and able to take telnet access. Ping 30.1.1.30, able to ping and also able to take telnet 30.1.1.30. You can see. Okay. Okay. Now we'll create the ACL. Configuration terminal. So I'll say access hyphen list. Number is, let's say, 100. Then what is my action? I want to deny. Which protocol I want to deny? ICMP. So I'll say ICMP. Who is my source? A single IP. So I'll say host and then 10.1.1.10. What is my destination? Single IP. Host 30.1.1.30. Now, which message I want to block? So if you see, if I want to block, I can block the echo request. That is the ping request. If I want, I can block echo reply. So right now I want to block echo request or reply. Request. So I will be using what? Echo. Or else, if you remember the type, type 8 is what? Request. Type 0 is what? So if you say here 8, that means it is request. If I say 0, reply. So either you can give the type number or directly you can say the echo. So let's say I want to block what? Echo. Done. Now I want to permit rest of the traffic. So I'll say access hyphen list 100 permit, and I want to permit all the internet protocols. So IP from any source to any destination. Spelling mistake. Done. Check. Do show access list. We have to deny the ICMP from this host to this host, and the type is echo. And I want to permit rest of the traffic. And after that, I have the deny statement, the implicit deny statement, that is deny all the internet protocols from any source to any destination. Okay, this is the implicit deny statement in case of your. Guys, any doubt? Naveen. So this is the implicit deny statement. Okay. Now see, we want to apply. We have created the ACL. Now we need to apply the ACL. So to apply the ACL, go to the interface. Let's say Z0 by 0. Okay. And Z0 by 0 will be our inbound. Okay. So I'll say IP access group. Then the number is 100 and direction is inbound. Clear? Now let's try to ping from PC1. See, earlier we were able to ping. Let me try to ping. 30.1.1.30. Am I able to ping?
Yes, no starting, no.
No. Okay. Did we block telnet? No. So we should be able to take telnet access. You can see. We are having telnet, but we have blocked what? Ping. Okay. Another thing, I said only unidirectional is blocked, means your PC1 cannot ping PC3, but PC3 we should be able to ping. Check. Ping 10.1.1.10. Only the request is blocked, reply is not blocked. Okay. Plus, you can see from PC2 and other, nothing is blocked. You can ping 10.1.1.10, able to ping. You can ping 30.1.1.30, able to ping. Okay. And even you can take telnet access. You can say telnet 10.1.1.10. 1, 2, 3. See. And even you can take telnet 30.1.1.30. This is clear. Any doubts so far? No. So this is the numbered method. Now in the named method, we will do the reverse. We will block telnet, we will allow ping. Okay. So let me remove the access list.
Sir, we can block echo request and reply simultaneously.
Yes, you have to create one more entry. Okay.
On same access. Same
Yeah,
access.
either you create one more entry, or else you just do not type this echo. So what will happen? All the ICMP protocol, entire ICMP protocol will be blocked.
Okay.
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 No, and then no access list 100. Okay, check. Do show access list. Nothing. Okay, then let's try to ping from PC1 to PC3. Earlier we were not able to ping. Right? We are able to ping, and also we are able to tell. That means no access list. Clear? All right. Now we will create the named. Named extended. Same steps. Number 1, create the ACL. How you are going to create your named command? Always start with IP. So you'll say IP access list. Okay, then you will say extended, and then you will give the name here. Okay. Then again, if you want, first of all, you can give the sequence number. Okay, that is optional. Then you will give what? Permit or deny statement. Okay, let me just copy paste. Remaining everything is same. Okay. Then this permit statement. To permit rest of the traffic. Clear? And application exactly similar. No difference. This is how you are going to apply your named access list. Port number 23. Noted? Okay, then let's go and create the ACL. So again, go to R1. We'll say IP, access list, extended name I want to give, block, PC1, telnet to PC3. Okay. Like this, you can give the name. Then after, first of all, deny. Now, telnet, which protocol? TCP or UDP?
TCP.
Uses port number 23, TCP. So you would say TCP. Then from which host? 10 to the host. Now you have to give what is the port number. So there is some options like equal to, greater than, less than, okay. But telnet works on a specific port number. So we'll say port number equals to 23. So either you can say 23 or you can say what? Simply telnet word also. Okay. So either you can say here the word telnet or you can say specifically port number 23. Both are your choices. Okay.
You can write in single line.
Hmm? Single line? No. In named method, you will just write this much, then you will go to the sub prompt. You see, it is now your, what is your prompt? Configure extended named ACL. Okay. In the numbered ACL, you will have to write in a single line everything. But in the named method, you don't have to do that. Okay. Plus in the numbered method, you have to write every time access list 100, access list 100 for each and every entry. Here, you don't have to do that thing. Directly give the permit or deny statement. This is clear. So you want port number or 23, or you can say telnet, both are same. Let's say I will say 23. And I want to permit rest of the traffic. So I'll say permit IP from any source to any destination. Done. Then apply it. Interface Z0 by 0. IP. Access group. Copy the name. Now on the Z0 by 0, it will be applied in inbound direction. Correct? On R1, on Z0 by 0, it will be in inbound direction. So I have blocked what? Telnet? Okay. Let's check. PC1. If I try to ping, I'm able to ping. Do I, like, am I able to take telnet access? Not able to take the telnet access. Okay. See. Why? It is getting filtered. But your PC2 and everyone else, they will be able to ping also. Take telnet also. Ping. Telnet. Oh, sorry. My mistake. One, two, three. Is that clear? Thank you. Okay. See, sometimes if you face problems like this, okay, if you think that you are, sometimes you mistype and get problems like this, then just simply do one thing. Let's say this is PC3, right? So on the routers, you specifically, you will face this problem. Okay, so all you have to do, just go to the global configuration mode and give the command no IP domain lookup. Okay. So what will happen? Now it will not look. See, whenever you type something, it tries to translate it from the domain server. So your router will start looking up the domains. So now you see, if I give like this, let's say 10, 1, 1, 30, 1, 2, 3. Now if I give any command, it will not do that. See, I will not wait for it. Okay. Clear? So on all the routers, you can give this command. This is clear.